This hilltop was once part of the backbone of America's first continental air defense network. The Nike Hercules anti-aircraft missile was the country's last line of defense against nuclear-armed Soviet aircraft. In the fall of 1957, the entire air defense system of the United States would be rendered obsolete by a new type of weapon. The technological breakthrough that unleashes this weapon is first realized more than a decade earlier. The V-1 is the Luftwaffe's response to the German Army's plan to bombard England. The V-1 is an effective terror weapon, yet remains vulnerable to anti-aircraft fire and fighter aircraft. V-2 was immune to the defensive weapons of the day. Diving at nearly 2,000 miles per hour, its silent but deadly arrival ushers in the age of the ballistic missile. The V-2 is Hitler's vengeance weapon, the secret he hopes will turn the tide of the war. Near the village of Peenemünde, Walter Dornberger and his technical director, Werner von Braun, supervised the development and testing of the V-2. Over 46 feet long and weighing 14 tons at liftoff, the V-2 can loft 1 ton of high explosives to a range of 150 miles. In 1944, more than 3,200 of the missiles are fired against London and Antwerp, Belgium. During that year, 5,000 people are killed by V-2 strikes on the European continent. At the end of the war, nearly all of the intact V-2 missiles fall into Allied possession. Von Braun and his missile corps surrender to the Allies. But the United States is not the only nation with an interest in Peenemünde. Most of the V-2 missiles are shipped to the White Sands Proving Grounds, where Operation Paperclip is initiated. Here, the very scientists that invented the V-2 would now develop the technology for the U.S. Army. The technological lead afforded Operation Paperclip fails to deter Soviet interest in ballistic missiles. Stalin learns the Germans had plans to build a long-range missile that could bombard the United States. he is quick to grasp the political importance of the transoceanic missile. Kapustin Yar. Soviet rocket scientist Sergei Korolev directs the reassembly and testing of captured V-2 missiles. The first V-2 copy, constructed with Russian-made components, the R-1 has a range of 185 miles and is operational by 1950. In the United States, there is no political mandate to develop a missile viewed by many to be technologically impossible. Manned strategic bombers are considered to be the only accurate intercontinental delivery system for nuclear weapons. Ballistic missile development is focused on short-range tactical weapons, like the Army's Honest John. In August 1949, U.S. ambivalence towards strategic missiles is shattered by the Soviet detonation of an atomic bomb. Fear of emerging Soviet technological achievements spreads through Washington. Funding for ballistic missile development is accelerated. The Army Ballistic Missile Agency initiates a program for a missile with a 500-mile range.
This is a model of the U.S. Army's Redstone guided missile, the largest American ballistic missile to have reached the test firing stage.
The Redstone contract is awarded to Chrysler in August 1952. The missile's 6,500-pound warhead limits the Redstone to a tactical range of only 175 miles. Tactical missiles can only threaten the Soviet Union from launch sites in Germany. The only way to match the Soviet threat to United States sovereignty is with a ballistic missile launched directly from the U.S. mainland. General Bernard A. Schriever is one of the first to suggest the H-bomb should be miniaturized to fit on an intercontinental ballistic missile, or ICBM. Traveling at 6,000 miles per hour, no known weapon can intercept an incoming ballistic warhead. Mathematician and Atomic Energy Commissioner John van Neumann and Dr. Edward Teller are commissioned to study warhead miniaturization. The Castle Bravo test in February of 1954 demonstrates that a tremendous yield could be generated by a dry fusion source weapon, making possible warheads of lighter weight. August 1954. General Schriever takes command of the Western Development Division. Its mission is to discover how to move an H-bomb 5,500 miles in 30 minutes. Convair is awarded the contract for development and testing of the Atlas missile. In the summer of 1955, based upon the findings of the Defense Department's Killian Report, President Eisenhower upgrades Schriever's ICBM program to top Defense Department priority.
So it was a combination of Gardner, the scientific community, Killian, that convinced Eisenhower that this had to be the number one priority. We could not afford to allow the Soviet Union to beat us to an operational ICBM. that was a race.
The Air Force begins work on the first Intermediate Range Ballistic Missile, or IRBM, known as the Thor. McDonnell Douglas is forced to build the first production round to be ready for testing in December 1956. The Thor test program is marred with difficulty. In one bold stroke, the USSR sweeps two spaceflight firsts from the grasp of the United States: the world's first artificial satellite and the world's first operational ICBM.
The Soviet launching of Earth satellites is an achievement of the first importance, and the scientists who brought it about deserve full credit and recognition. Already, useful new facts on outer space have been produced.
Today, a new moon is in the sky, a 23-inch metal sphere placed in orbit by a Russian rocket. A three-stage rocket. Number one, the booster in the class of an intercontinental missile. Its weight estimated at 50 tons. The smaller second stage took over at 5,000 miles an hour and carried on to the highest point reached. 500 miles up, the artificial moon is boosted to a speed counterbalancing the pull of gravity and released.
Far overshadowing the launch of the 184-pound satellite, Korolev's R-7 is capable of lifting the 10,000-pound, 5-megaton Russian thermonuclear warhead. Maintaining close links with the Soviet space effort, British astronomer Sir Bernard Lovell and the Jodrell Bank radio telescope were frequently called upon to track Soviet satellites and probes.
I think it was simply that the Americans did not believe in the successful development of Soviet technology.
The United States Armed Forces wrestle with the realization they've been caught short. Thor's production is accelerated. The Atlas development program is accelerated as well. The developers of Atlas are never certain its test program will produce an operational missile.
We had some losses. We had 5 Atlas failures in a row. In those days, they were willing to take the risk because the risk was very high in terms of if we didn't make it.
Premier Nikita Khrushchev builds upon the momentum of Sputnik with a series of threatening pronouncements. We have the absolute weapon. We have the ICBM. We have all the bombs, A bombs and H bombs. In this respect, we have proved our superiority. Khrushchev warns that Russia could tomorrow put up 10 or even 20 new Sputniks, and each Sputnik means the expenditure of the kind of super missile the United States does not yet possess. Eisenhower turns to the Army Ballistic Missile Agency and Wernher von Braun. On January 31st, 1958, the Army's Jupiter-C successfully launches Explorer-1 into orbit, the first United States artificial satellite. Explorer-1 makes an unexpected scientific discovery. The satellite detects a belt of charged electrical particles trapped within the magnetic fields surrounding the Earth. The belts are named after project leader Dr. James A. Van Allen. December 1957. The CIA and a scientific advisory committee meet to review a classified report by a scientist named Nicholas Christophilus. Energy, radiating from the sun, becomes trapped in the magnetic pull of the Earth. This band of high-intensity radiation extends from 500 miles to as much as 40,000 miles above the Earth. During periods of extreme solar activity, the quantity of this captured radiation rises in the Van Allen belt. Occasionally, these high-energy particles leak into the atmosphere at the geomagnetic poles, resulting in colorful and mysterious auroras. Christophilus surmised that if a source of highly charged electrons, such as that from a nuclear detonation, were injected at an altitude of a few hundred miles, even a 1 megaton explosion would create a radiation hazard, foiling United States satellite attempts in space. Christophilus's work becomes the genesis of a secret program.
The objective of the Argus experiment was to take a close look at the phenomena associated with the trapping in the Earth's magnetic field of relativistic electrons produced by nuclear detonations at very high altitudes. It was necessary to learn the governing parameters of these phenomena so we could make reliable estimates of their military importance. There seemed to be a good possibility that they were very important, and for that reason, there was a pressure on this entire operation to secure quick results.
In April of 1958, the Department of Defense implements Project Argus as one of the largest clandestine operations ever attempted. A fleet consisting of 9 ships headed out for the South Atlantic. It is here that the Earth's magnetic field dips to its lowest point in what is known as the South Atlantic Anomaly. 3 X-17A missiles are launched from the deck of the USS Norton Sound. The missile's 1 kiloton warhead detonates at an altitude of 300 miles. As Christophilus had predicted, charged particles from the detonation travel along the lines of the Earth's magnetic field, temporarily creating a new belt of high-intensity radiation. One of the most significant findings of Argus is that the detonation of a nuclear device in the ionosphere could create selective blackouts of radio communications.
The Argus explosions completely disrupted the ionosphere. This ionosphere was still the main source of long-distance radio communication across the oceans.
The United States augments the Argus program with a series of high-altitude nuclear tests in the Pacific Proving Grounds. The teak shot of Operation Hardtack is scheduled to be launched from Johnston Island, a remote location 715 miles southwest of Honolulu, Hawaii. the Atomic Energy Commission chooses von Braun's Redstone missile to conduct the tests. The Teak fireball began to affect communications over a wide expanse of the Pacific. Radio frequencies are disrupted throughout most of the basin. In Honolulu, commercial air traffic is suspended for many hours because of the failure of long-wave communications.
As it was, one of those two high-altitude shots did affect the power grid on Oahu, knocking out quite a bit of it. That was unexpected.
The emergence of this new world poses a vital issue. Will outer space be preserved for peaceful use and developed for the benefit of all mankind? Or will it become another focus for the arms race, and thus an area of dangerous and sterile competition? The choice is urgent.
On October 1st, 1958, President Eisenhower's plan to shift control of space exploration away from the military takes effect. The National Aeronautics and Space Administration assumes management of 4 lunar probes and 3 other satellites. NASA directs the launching of weather, navigation, and communication satellites, all directed toward the purpose of peaceful scientific research.
This is Telstar Control at Canelo. We've got good news. I think we've got our orbit.
By November of 1958, the United States, Great Britain, and the Soviet Union begin test ban negotiations in Geneva. With the exception of 3 French tests in the Sahara, the world is spared the rumble of atomic blasts for the next 34 months. However, the test ban does nothing to impede the development of delivery systems for weapons of mass destruction. By the end of November, the first successful flight of the Atlas A ICBM launches a dummy warhead 6,300 miles downrange in the South Atlantic. Within 2 years, a dozen Atlas D missiles are deployed and operational. The first hardened squadron of Atlas launchers are turned over to the Strategic Air Command in August 1960. The missiles are deployed within blast-protected structures called coffin launchers. Even greater protection is afforded by the silo launcher. The new Titan ICBM is designed for silo launching. The Titan I is heavier, sturdier, and has greater lift capacity than the Atlas. While the early models of the Titan I are armed with a 3.8 megaton warhead, the Titan II would become the largest ICBM the United States would ever deploy. Though its development benefits from more lead time and lessons learned in the Atlas program, the Titan test series is not without failures. By the end of 1961, Atlas squadrons expand to a total of 57 operational missiles. Uncertainty over the potential glut of Soviet ICBMs presses upon military planners. The R-9 and R-16 are competing designs for the Soviet response to the Titan I, each with a range of 6,000 miles.
You can't hide an ICBM. They had a test facility that we could monitor, so we knew when they fired a missile, when they had a failure, and so forth and so on.
Heightened awareness of the Soviet ICBM program leads to enhanced surveillance techniques. In the summer of 1960, the first United States spy satellite, codenamed Corona, photographs suspected missile bases. The photos reveal that the entire Soviet ICBM arsenal consists of only 6 missiles. The widely reported missile gap favoring the Soviet Union is found to be fictional.
I testified before the Congress on a number of occasions, and I said there is no gap. We're ahead of them, and we were ahead of them for 2 reasons, primarily. Well, there were many, but one is we were there first with a thermonuclear weapon. And we were there first with a solid propellant.
An inherent deficiency, shared by both the U.S. and Soviet ICBMs, is their use of non-storable liquid fuel. Liquid fuel missiles require hazardous and time-consuming fueling procedures prior to launch. The greatest disadvantage of these missiles is response time. With the early warning for ICBMs coming over the pole at 15 minutes, rapid response is critical. Solid fuel missiles, however, can be launched on command. Advances in solid fuel propulsion lead to the contract for the Minuteman, the world's first solid fuel ICBM. Holding a temporary advantage in numbers of strategic missiles, the United States has reason to remain vigilant when it comes to Soviet nuclear weapons expertise. The Soviets detonate a 50-megaton clean version of their 100-megaton superbomb. Concern arises that the U.S. is falling behind in nuclear weapons development. The next month, the Soviets conduct several high-altitude tests. The results permit them to develop data similar to that of the Teak and Argus series. General Bernard Schriever expresses concern that the USSR is developing an anti-ballistic missile that could stop every missile fired by the United States.
By 62, ABM systems, anti-ballistic missile systems, were firmly entrenched in the defenders' minds.
The potential for a functioning Soviet ABM poses new challenges to ICBM warhead design. The outcome of this research is the cluster warhead. Multiple warheads make it more difficult for a single ABM missile to destroy an incoming ICBM. The United States pursues development of its own anti-ballistic missile, the Nike Zeus. However, the data to support the nuclear kill mechanism employed by the Nike Zeus can only be obtained through high-altitude tests.
"17 years ago, man unleashed the power of the atom. He thereby took into his mortal hands the power of self-extinction. And when all nuclear powers refrain from testing, the nuclear arms race is held in check. But on September 1st of last year, while the United States and United Kingdom were negotiating in good faith at Geneva, the Soviet Union callously broke the moratorium with a 2-month series of tests of more than 40 weapons. Having carefully considered these findings, I have today authorized a series of nuclear tests to take place in the atmosphere over the Pacific Ocean."
Agent Orange left all sorts of questions. Then when we were allowed to come back and test in the Operation Dominic, the Fishbowl series, and Fishbowl was reserved for the high-altitude tests, and we did 6 more. Most of the experiments were related to communications degradation, high-altitude EMP, and radar blackout, and radar jitter, radar scattering.
Recalling the disturbance caused by the Argus tests, the reaction within the world scientific community is negative toward the so-called rainbow bombs.
We did not know whether the American scientists had carried out proper calculations and could give an assurance that there would be no serious disturbances of the natural environment.
It has been the stated policy, as you said earlier, for this government to restrict outer space for peaceful objectives only. Will not the proposed H-bomb explosion 500 miles up jeopardize this policy and objective?
No, I don't think so. I don't think so.
Mr. President.
I know there's been disturbance about the Van Allen belt, but Van Allen says it's not going to affect the belt. It's his...
Starfish Prime, the first test in the Fishbowl series, lifts off from Johnston Island atop a Thor missile. Reaching an altitude over 5 times higher than Teak in 1958, the Starfish Fireball enters the Van Allen belt, igniting a violent auroral display. The bomb's electromagnetic pulse effect is pronounced in Hawaii, causing blown fuses and radar blackouts throughout the Hawaiian Islands. A shower of highly charged radiation spreads rapidly into the regions of near space frequently traveled by Earth's artificial satellites.
Good evening. We made a last-minute change of plans tonight, and the second test of Telstar, our worldwide...
French television officials transmitting through their ground station are going to transmit a special telecast.
This achievement, which is another first in our conquest of space.
And the part of today's press conference being relayed by the Telstar communications satellite, viewers across the Atlantic.
Telstar 1, the Earth's first telecommunications satellite, launched one day after Starfish, is damaged by the intense radiation belt and ceases to transmit 7 months later. Beginning 3.5 days after Starfish, a British scientific satellite, a Navy navigational satellite, and research satellite ceased to transmit.
It just showed that if you didn't harden a satellite, that you could induce changes in the electronics that would cause them to fail, or at least hiccup.
Noting the radiation damage to satellites, the Russians sent a communique to Washington imploring them not to conduct any tests that would endanger the health of their orbiting cosmonauts.
There's some concern about the possibility of bluegill getting something up to levels that will have some effect on the man in space.
By September of 1962, the White House learns that the Dominic tests are creating conditions that could irradiate men in space.
We would really be concerned that if the electrons now were increased by a factor of, say, 10 times. I think that would almost rule out the flight.
I think NASA is justifiably worried about the present 8R estimates of the dosage.
Debate arises over schedule conflicts between upcoming tests and planned manned launches.
While we do not believe that Test Bluegill or Test Nike Hercules currently scheduled for 17th and 22nd will do more than very temporary damage to this orbiting area. We don't know that. It would certainly be necessary to measure the atmosphere before sending up Mr. Sharon.
Wally Schirra's Mercury 8 mission is launched on October 3, 1962. He is instrumented with radiation dosimeters and film badges to monitor radiation exposure on his spacecraft as well as on his spacesuit.
That's a fan. What's your problem?
The most controversial of the proposed tests is codenamed Uraka, the detonation of a megaton device 500 miles into space, well within the Earth's protective Van Allen belt.
What about Uraka? See, the Uraka, I would like to ask an irreverent question. I get the impression that there's 3 cases. Go out and see what happens. You don't really know. Well, like I said, it's worse than that, you know.
Reacting to worldwide pressure, Uraka, the highest test in the series, is canceled. Meanwhile, the Bluegill test series encounters mounting technical difficulties at Johnston Island. The first Bluegill Thor missile lifts off on June 4th, 1962. A tracking beacon failure forces the range safety officer to destroy the missile in flight. The next attempt at Bluegill is destroyed on the launch pad. Severe plutonium contamination results from the warhead's safe destruction.
Because of the blow-up in the pad at Johnston Island, we are not able to carry out these tests, which were among the most important, if not the most important of our series. So we're going to finish those. This government has maintained the closest surveillance of the Soviet military buildup on the island of Cuba. Within the past week, unmistakable evidence has established the fact that a series of offensive missile sites is now in preparation on that imprisoned island. The purpose of these bases can be none other than to provide a nuclear strike capability against the Western Hemisphere. Nuclear weapons are so destructive and ballistic missiles are so swift that any substantially increased possibility of their use or any sudden change in their deployment may well be regarded as a definite threat to peace.
October 24th, 1962. A shipping quarantine on Cuba is imposed by President Kennedy. United States strategic forces are upgraded to DEFCON 2, the highest ever under peacetime conditions.
I have reinforced our base at Guantanamo and ordered additional military units to be on a standby alert basis.
On that same day, a Russian Mars probe launched from Baikonur explodes shortly after liftoff. The missile fragments are visible to observers at the U.S. Ballistic Missile Early Warning System, who nearly conclude a Soviet missile attack is underway. Within moments, the system's computer calculates the fragment trajectories and determines the alarm to be false. October 25th. Amidst escalating world tensions, Bluegill Triple Prime is successfully launched and detonated.
Some other activities that were even more dangerous, the launch of a test ICBM by the United States from Vandenberg Air Force Base in California. That was especially alarming because under the DEFCON 3 alert, most of the test launchers and missiles at Vandenberg had been rapidly converted to wartime use with nuclear warheads. Now, the Russians presumably were aware that we were converting that test facility into an additional operational facility. And at the time, someone went ahead with a planned firing of a test ICBM over the Pacific.
On the 28th, at the height of the crisis, the Soviets conduct a high-altitude nuclear test requiring the launching of 3 ballistic missiles.
The Soviets fired 3 1,100-mile missiles yesterday to Clifton Yard for its parachute down. The first missile carried a 200-kiloton payload. The other 2 missiles were fired through the burst in order to test elements of the anti-missile system in the nuclear burst environment.
October 29th. Khrushchev considers evidence that his Cuba policy is spiraling out of control. Faced with unanticipated United States resolve, Khrushchev agrees to withdraw the missiles from Cuba. November 1st. White House struggles to verify that Soviet missiles in Cuba have in fact been disabled. Despite this destabilizing factor, both the U.S. and the Soviets conduct high-altitude nuclear tests on the same day.
5, 4, 3, 2, 1, 0.
danger of situations simply getting out of control from developments and accidents and incidents that neither side, leaders on either side, were not even aware of, much less in control of, could have led to war.
Following Tightrope, the final atmospheric test by the United States, negotiations begin for the Test Ban Treaty of 1963. By 1965, Washington decision-makers are convinced that the Russians lack the numbers of long-range bombers to justify the continuance of a continental air defense system. Rapid expansion in ICBM deployment indicates that the Soviets' primary nuclear threat to the United States is through strategic missiles. Over the next 10 years, the Soviet ICBM force will grow to nearly 1,500 nuclear-tipped missiles. By comparison, the U.S. ICBM force grows to over 1,000 ICBMs armed with more than twice as many warheads.
The degree of overkill was enormous, and it's no good protecting oneself against 80% or 90% of such missiles, because the remaining few percent become immensely destructive.
On October 1st, 1975, the Minuteman ICBM force was briefly shielded from a Soviet first strike by a missile defense known as Safeguard. Developed at a cost of over $20 billion, Safeguard was the United States' only deployment of an ABM system. Convinced that Safeguard's radar could be blinded in a nuclear attack, Congress votes to deactivate the site the very next day. In Russia, there is no debate over ABM. The Galosh Gazelle dual interceptor based around Moscow remains the only operational ABM system in the world today. The United States currently has no such protection. Most of the Nike Hercules anti-aircraft missile batteries were dismantled by the mid-1970s. This site was last active in 1974. During and since the reign of President Reagan's Strategic Defense Initiative, the United States has spent over $60 billion on the development of ABM technology. Not one of the concepts has proven effective.